Hi everyone, in this video I am going to solve Cambridge International AS and A Levels Pure Mathematics 1 in a session May-June 2022 paper 1-1. So let's start with the first question. Question number 1, part A, express the standard form of a quadratic equation into vertex form where P and Q are constant. Okay, so to convert the standard form into vertex form, first we have to take the coefficient of x square common from the first and the second term since it is just 1. So we can take x square minus 8x and plus 11. Okay, now in the next step what we have to do, we need to take the coefficient of x, that is negative 8, divided by 2, which is equals to minus 4, and take its whole square, which is equals to 16. So we have to add and subtract 16 inside the bracket. X square minus 8x plus 16 minus 16 and plus 11 is outside. Okay, then the next step is we have to combine the first three terms with the plus 16 and taking the negative 16 outside. 11, negative 16, we have just 1 outside, so minus 16 times 1 is just minus 16. Okay, now here we have to complete the square, which is x minus 4 whole square, and 11 minus 16, this is equals to negative 5. So this is in the form of x plus p whole square plus q. So we can say that where p is negative 4 and the q value is negative of 5. Right. Now moving to part B, hence find the exact solution of the equation, putting this quadratic equation equals to 1. Okay, so as we know that the solution for this quadratic equation is x minus 4 whole square minus 5, put it equals to 1. We have x minus 4 whole square equals to 1 plus 5, which is equals to 6. X minus 4 whole square equals to 6, right? Now to get rid of square, you have to take square root on both sides. Taking square root on both sides. Right, so you have x minus 4 and this is equals to plus minus square root of 6. Right, now we have two values for x, so let me simplify. X is equals to 4 plus minus square root of 6. Right, this is a solution. Question number 2, the 13th term of an arithmetic progression is 12 and the sum of the first 30 terms is negative 15. Find the sum of first 50 terms of the progression. Okay, so we have given the 13th term and the sum as well. So let me use the formula for the term and the sum. For arithmetic progression, we have the term a(n) equals to a1 plus n minus 1 into d, and the sum formula is Sn equals to n by 2 into 2a plus n minus 1 into d. So this a is just the a1, right? Okay, now we have given the 13th term when n is equals to 13, so we can say that a plus 13 minus 1, that is 12d, this is equals to 12. This is my first equation. Right, okay, and the sum of first 30 terms when n is 30, as 30 we have given, so this is 30 divides 2 into 2a plus 30 minus 1, this is equals to 29d, this must be negative 15. Right, let me simplify this equation. This is 15, 2a plus 29d equals to 15, negative 15. So we can cancel the 15 with the negative 15. So we have 2a plus 29d. This is equals to negative 1. This is my second equation. Okay, now we have two equations in A and D. We can solve the two linear system of linear equations by using method of substitution or elimination to get the value of A and D. Okay, so if I can multiply the first equation with 2, let me write, and subtract with 1. Multiplying equation 1 by 2 and subtract in equation 2. Let's do this. Equation 1 is multiplying by 2, so we have 2a and 12 times 2, that is 24. Yes, we have 24d and 12 times 2 is again 24. The second equation is same, 2a plus 29d equals to -1, right? Now we have to subtract the two equations, so basically we have to change the signs, negative, and this changes to positive. Okay, now what happened? Plus 2a minus 2a is just cancel out, we have 0. 24 minus 29, 24 minus 29, this is minus 5 d, and this is equals to 24 plus 1, this is equals to 25, and d equals to 25 divides minus 5, -5. So the d value is -5. We got the d, that is -5. Now let's substitute the d value into the first or second equation to get the a value, right? So let me put into the equation 1, right? Put d equals to -5 in equation 1. Right, so we have equation 1, a plus 12 times of d equals to 12. Okay, 12 times of d, minus 5 times 12, this is -60. So we have e plus -60 equals to 12. So a equals to 12 plus 60, right? So we have 12 plus 60, this is 72. So we got the a value, which is equals to 72, and the d value is -5. Okay, now moving back to the question, it says find the sum of the first 50 terms. Sum of the first 50 terms of the progression. Since it is arithmetic progression, so we have to find the sum of first 50 terms, which is Sn. This is n by 2 into 2a plus n minus 1 into d. Right. So let me find S50. When n is 50, S50, this is equals to 50 by 2, 2 times of a, that is 72, plus 50 minus 1, and the d is -5. I just substitute all the terms, right? Okay, so S50, 50 by 2, this is 25. Let me simplify. 2 times of 72, 144. 50 minus 1, this is 49 times -5 minus 2, 45. Add in 144 minus 101 and times by 25, this is minus 2525. This is the sum. Okay, so S50 is minus 2525. This is the sum of the first 50 terms of the progression. Question number 3, the coefficient of x power 4 in the expansion of this is a, and the coefficient of x square in the expansion of this is b. A part, find a and b in terms of constant k. Okay, so let me solve for a. So that is a coefficient of x square. X4 coefficient is a. Okay, so if I open this binomial expansion, we have 2x square plus k square over x whole power is 5. Right, so we have 2x square whole power is 5 plus 5c1, 2x square power is 4 and k square over x plus 5c2, 2x square is cube and k square over x whole square plus 5c3, 2x square, its power is 5, 4, 3, it's 2 now, and k square over x power is increasing by 1, 0, 1, 2, it's 3, plus 5c4, we have 2x square power 1 and k square over x, its power is reducing by 1, increasing by 1, it's 4, and the last term is 5c5 and k square over x, its power is 5. Right, now we have to pick the coefficient of x4. Okay, here we will get x power 2 times 5, 10, not x4. Okay, so okay, let me open all the terms again. Okay, so 2x square power 5. So we can say 2 power 5, which is 32, and x power 2 times 5 is 10. Okay, 5c1, what is 5c1? This is 5, and 2 power 4, which is 16, times 5, which is 80. Okay, and we have x power 2 times 4 is 8, k square over x, right? Plus 5c2, 5c2, sorry, we can say 2, 10, and 2 cube is 8, 10 times 8 is 80. We have again 80, x power 2 times 3 is 6, and k power 4, and x square, right? And so on. Let me stop over here. So here you can see, if I cancel this, you will get 7, square and square cancel, you will get 4 over here, right? So you have the coefficient of x power 4. Okay, coefficient of x power 4. What is the coefficient of x power 4? Which is 80 k4, and this is your a value. They said the coefficient of x power 4 in this expansion is a, so we can say the a value is 80 k power 4, right? Now let me open the second expansion to get the b, the value for b, which is the coefficient of x cube. Okay, the second is 2kx minus 1 power 4. Okay, so 2kx power 4, 4c1, 2kx power is 3 minus 1, 4c2, 2kx power 2 minus 1 square, plus 4c3, 2kx minus 1 cube, plus 4c4 minus 1 power 4, right? Okay, simplified further. 2 power 4 is 16, k power 4, x power 4, right? What is 4c1? We have 4c1, which is 4 times 2 cube is 8, which is 32. So we have 32 k cube x cube with a negative sign. Okay, plus 4c2, 6, and 2 square is 4 times 4, which is 24 k square x square, and this is just 1, plus so on. So we got the coefficient of x square, right, in the second expansion. Okay, so we can say that the coefficient of x square, what is the coefficient of x square, which is 24 k square, and this is my b value, right? So we got the value for a and the value of b. Now for part b, given that a plus b is equals to 216, find the possible values of k. Okay, so we have the a value from first part, which is 80k4, plus the b value is 24k square. This is equals to 216. We have to solve for k. So 80k4 plus 24k square minus 216, this would be equals to 0, right? Okay, so let me divide throughout the term by 8. Yes, okay, dividing by 8 to simplify it. 8 times 10 would be 80 k4. 8 times 3 is 24. Okay, what is 216 divides 8? This is 27. Okay, minus 27, this would be equals to 0. Okay, now let me use a substitution. Let k square would be equals to x, right? So we have another equation, 10x square plus 3x minus 27, this would be equals to 0, right? So this is a quadratic equation in a variable x. So let me use the factorization method here. So we have 10 times minus 27 is minus 270, and if I can do 18 times minus 15, this is minus 270, and 18 minus 15 gives me 3, right? So 10x square plus 18x minus 15x minus 27, this would be equals to 0, right? Okay, let me take 2x common from the first term. 2x, just 2x. 2 times 5 is 10x, and 2 times 9 is 18. Minus, you can take minus 3 common. 3 times 5 is 15x, and 3 times 9 is 27 with a positive sign, right? So the two factors are 2x minus 3, and we have 5x plus 9. This would be equals to 0. Let me substitute both factors separately equals to 0 to get the value for x. So from here we have 2x minus 3 would be equals to 0, and 5x plus 9, this would be equals to 0. So 2x would be 3, and x is equals to 3 by 2, right? And here 5x is equals to minus 9, and from here what is x? X is minus 9 over 5. Okay, now let me put the substitution back. We substituted x as k square, so we have to put it back. X is your k square, so we can say k square is 3 by 2, and here k square is minus 9 by 5, right? Now let me solve for the k values. We have to find all the possible values of k. So here the k value is plus minus square root 3 by 2, right? And here the k value is plus minus square root minus 9 by 5. So we are not considering this value because here you will get the complex number. So we are only dealing with the real part, right? So the possible values of k are just k equals to plus minus square root of 3 by 2. Question number 4, part A, prove the identity left hand side must be equals to the right hand side. So let me start from the left hand side. So as you can see on the left hand side, we have to take the LCM. We do the cross multiplication first. So sine cube theta is going to multiply with the opposite denominator, sine cube theta into 1 plus sine theta, and minus sine square theta is going to multiply with sine theta minus 1, right? And this is going to divide with sine theta minus 1 and sine theta plus 1, right? In the next step, let me multiply sine cube theta plus sine power 4 theta. Okay, so minus sine cube theta, and minus times minus is plus sine square theta, divides sine theta minus 1, sine theta plus 1. A minus b into a plus b is sine square theta minus 1 in the denominator, right? Okay, so further simplification, you can cancel sine cube theta, right? Sine 4 theta plus sine square theta over, what is sine square theta minus 1? Okay, let me use the identity sine square theta plus cos square theta equals to 1. Sine square theta minus 1, shifting the 1 over here, this is minus cos square theta. Okay, let me use this. This is minus cos square theta, right? Okay, now in the next step, let me take sine square theta common from the numerator. So we have sine square theta is common. We have sine square theta plus 1 divides minus cos square theta, right? So sine over cos is tangent minus tan square theta into 1 plus sine square theta. This is my right hand side. You can see minus tan square theta into 1 plus sine square theta. So the left hand side is proved to the right, left hand side equals to the right hand side. Now for part B, hence solve the equation for theta is between 0 to 2 pi. Okay, so from first part we know that sine cube theta over sine theta minus 1 minus sine square theta over 1 plus sine theta. This would be this side, left hand side, is equals to minus tan square theta into 1 plus sine theta, sine square theta, right? And this is equals to tan square theta into 1 minus sine square theta, right? Let me simplify. Minus tan square theta minus tan square theta sine square theta equals to tan square theta minus tan square theta sine square theta. Sorry, I have theta here. Okay, so minus tan square theta sine square theta minus tan square theta sine square theta is cancelled. So let me shift this term on the other side. We have tan square theta plus tan square theta. This would be equals to 0. 2 times of tan square theta, this would be equals to 0, or you can say tan square theta, this would be equals to 0, right? Okay, taking square root again, so tan theta would be equals to 0. So what is theta? Theta is tangent inverse of 0, right? The domain is between 0 to 2 pi. We have to do in radians. The calculator is already in radians. So tangent inverse of 0, this is equals to 0, right? So we have theta would be equals to 0. And we know that tangent is positive in which quadrant? Let me draw the coordinate system, because here the tangent is positive. If I draw the coordinates, we know that we have to use a cast rule. So tangent is positive in first and in third quadrant. So first quadrant you have 0, and for third quadrant we use operation 2 pi plus theta, right? Sorry, pi plus theta. Yes, you have theta here, you have pi minus theta, here you have pi plus theta, and here 2 pi minus theta, right? Pi plus theta, so pi plus 0, so theta is equals to pi. So these two values belongs to the domain. No, 0 does not belongs to the domain, sorry. As you can see, the domain 0 is not including and 2 pi is not including, right? So we can say that the only solution is theta equals to pi, which belongs to the domain between 0 to 2 pi, right? Question number 5. The diagram shows a sector A, B, C with the center A and the radius R. It means AB is R and AC is also R, right? So A to C, this is also equals to R. The line BD, B to D, is perpendicular to AC. BD is perpendicular to AC, and angle CAB, this is theta radians. In part A, given that theta is pi by 6, find the exact area of BCD in terms of R. BCD, so you have to find this area. So the exact area of BCD is basically area of the sector minus area of this right angle triangle, right? So first we have to find the area of a sector and then subtracting with that one, right? So we can say that area of BCD is sector area minus triangle area, right? Let me start with the sector area. Area of sector, the sector ABC, right? Area of a sector ABC, since it is in angle is in radians, so we have a formula half r square theta, radius square and theta. Okay, so what is the radius? Radius is r, theta is pi by 6. So just substitute. We have half r square, theta is pi by 6. So the answer is pi over 12 r square. This is my pi by 12 r square. This is the area of a sector, right? Okay, now to find the area of a triangle, as we can see that we know just one side of the triangle and this angle, and it is a right angle triangle. In terms of r we have to find, so we can find the side AD and BD, right? Let me draw this triangle separately. This will be clear here. Okay, So I have a right angle triangle over here, right? So the right angle is D, this is A, and the line is B. BD is perpendicular to this side, right? So AB we have given is R, and this is pi by 6, right? Now let me find the value of AD and BD, right? Okay, so this is opposite over hypotenuse. So if I can say sine pi by 6, sine theta opposite over hypotenuse, this is BD over the hypotenuse is R. So from here BD is equals to R times sine pi by 6. What is sine pi by 6? Sine pi by 6, 1 by 2, R by 2, right? Okay, now cos pi by 6. Cos is adjacent over hypotenuse, AD over R. So what is AD? From here AD is R times of cos pi by 6. So from here we can say we have cos pi by 6, square root of 3 by 2. Square root of 3 divides 2, right? Now we have all the values. This is square root of 3 by 2R, and this is 1 by 2R, right? Okay, now let me find the area of a triangle. Area of right angle triangle is half base times height. Half, the base is AD, which is square root of 3 by 2 times R, and the height is R by 2, right? Further simplification, we have square root of 3 divides 2 cube is 8 and R square, right? Okay, now let me substitute this into the formula. So we can say that area of BCD in terms of R is area of a sector, which is pi by 12 R square, minus area of a triangle, square root of 3 over 8 R square, right? So this is exact area of BCD in terms of R. Now for part B, given instead that the length BD is square root of 3 by 2R, find the exact parameter BCD in terms of R. Okay, so what we have given? We have given this is a shape that the length of BD, B to D, this length we have given, this is square root of 3 over 2 times R, right? And we have to find the exact parameter BCD, this parameter. Okay, so to find this parameter, we have BD, we have to find BC and BC, this, and DC. Okay, so for BC, this is the arc length of a sector, right? So let me use the arc length of a sector first. But before using the arc length, we have to find the angle theta, because theta is not given in this question, right? If we have given the theta pi by 6 for part A, but it is not, we are not using for part B. So what we have to do, we have a right angle triangle A, B and D. So we have one side AB, at the other side BD. We can find the third side by using Pythagoras theorem, right? And when we have the third side, we can easily find out the angle, the angle between them. Yes, so let's do this. Okay, considering this right angle triangle, this is easy to visualize. A, D and B, it is a right angle triangle. This is a base, this is perpendicular, and this is the hypotenuse. So hypotenuse square equals to the sum of square of the other two legs of the triangle. So we can say the hypotenuse is x, this is square root of 3 by 2x, R, square root of 3 by 2R, and this is unknown, AD we don't know, right? So let me solve this by using Pythagoras theorem, that AB whole square, this would be equals to AD square plus BD square, right? So AB is R square, we have the same, radius is the same. AD we don't know, AD square, plus BD, we have given BD, which is square root of 3 over 2 R whole square, right? So R square minus 3 by 4 r square, this is my AD square, right? So what is 1 minus 3 by 4? So let me simplify. Minus 3, okay, 1 minus 3 divides 4, which is 1 by 4. So this is r square by 4. This is your AD square. Now what is AD? AD is r by 2, right? So this is your AD, which is equals to r by 2, right? Okay, now let me find the angle theta to get the arc length, this arc length. How can we solve for angle theta? Let me draw this triangle to get angle theta easily, right? Okay. We have all the three sides. We can easily use a ratio for sine, cos, or tangent to get the value for theta, since it is a right angle triangle, right? Okay, so the perpendicular is D and B, and this is A. We have to find this theta. We have, this is 1 by 2 r, AB is r, and this is square root of 3 by 2 r, right? Okay, let me use the ratio for sine or cos. This is your choice. So sine theta is opposite over hypotenuse, cos is adjacent over hypotenuse, and tangent is opposite over adjacent, right? So if I use sine theta, this is opposite over hypotenuse. Opposite is square root of 3 by 2, square root of 3r by 2 over r. This is opposite side and this is adjacent. We can cancel r and r. So we have square root of 3 by 2. Right. So what is theta? Theta is sine inverse of square root of 3 by 2. Right. Sine inverse, sorry. Okay, let me simplify. Sine inverse square root of 3 divided by 2. Pi by 3. Okay. So now theta is pi by 3. This theta is pi by 3. Now let me find the arc length, right? Because we need BCD. Okay, so arc length CD in terms of radians, this is equals to r square, r times theta, sorry, not r square, r times theta. Radius is r, theta is pi by 3. So this is just pi r by 3, pi by 3 r. Right, this is my arc length, right? And we have to find the parameter of BCD. So to find the parameter of BCD, we have BC, we have B to D. Let me find what is DC, right? Since the sector is the same and this would be R, this is half R, so this is obviously equals to half R, because half plus half is just 1, right? So DC is also half R, right? Okay, D to C is 1 by 2 r, right? Now let me add up to get the parameter, right? Okay, we can say that the parameter is the sum of DC, DBD, and BC, right? Okay, so what is DC? DC is 1 by 2 r. DB is given square root of 3 by 2 r, and BC, where is BC? BC is this, pi by 3 r. So this is a parameter of BCD in terms of r. Question number 6, the function f is defined as follow. F of x you have given and the domain is x is greater than 2. Part A, find an expression for f inverse of x, right? So to get f inverse of x, first step we have to put y equals to the function f of x, which is x square minus 4 over x square plus 4. And then the next step we have to switch the variables. X is equals to y square minus 4 over y square plus 4. Right, now doing a cross multiplication, xy square plus 4x would be equals to y square minus 4, right? Okay, now shifting the y terms to the left side and the constant terms to the right, minus 4x. Taking y square common, we have x minus 1, this is minus 4x, right? Okay, so y square would be equals to minus 4x over x minus 1, right? Or we can take y square is equals to 4 plus 4x over 1 minus x. And what is the value for y? Y is equals to square root of 4 plus 4x over 1 minus x, and this y is my f inverse of x, right? Now for part B, show that 1 minus 8 over x square plus 4 can be expressed as this, and hence state the range of the function. Okay, so first taking the LCM, we have x square minus 4 plus 4 minus 8 over x square plus 4, and this would be equals to x square minus 4 over x square plus 4. This is your function f, right? Now we have, this is f of x. Now we have to state the range of the function f of x, right? So we have given the domain in the first part, that the domain of the function f of x is greater than 2, means 2 to infinity, right? So if I substitute x is equals to 2, right, at x is equals to 2, what is f of x? F of 2, the output, we have 2 square minus 4 over 2 square plus 4, right? So what is this? 2 square is 4, 4 minus 4, this is just 0, right? And at x is equals to infinity, if you put infinity, so f of infinity, because all the values that are greater than 2, 3, 4, 5 up to positive infinity. So we have infinity square minus 4 over infinity square plus 4, right? This is undefined form, so in to get rid of undefined form we have to use an L'Hopital rule. So or we can substitute into this function 1 minus 8 over x square over 4. This is undefined form, infinity over infinity form, so we can put f of infinity into 1 minus 8 over infinity square plus 4. Okay, so infinity square is infinity, infinity plus something is also infinity, and something dividing by infinity is 0. So 1 minus 0, this is equals to 1, right? Okay, so when we put 0, we got at 2 we got 0, at infinity we got 1. So what is a range? We can guess the range, that the range is between 0 and 1. So we can say that the range of f of x is all the values that are between 0 is less than f of x is less than 1. We are not using the equality because the equality is not using over here. We are not using equals to 2 value. At 2 it is 0, so we have to do between 0 and 1, and we cannot take at infinity is not the exact value, so that is why it is not equality. They're just the interval between 0 to 1. Okay, now for part C, explain why the composite function f, composition f, cannot be found. Okay, the reason is f composition f of x cannot be formed because what we have to do the range of the inner function, right? What is the range of this f of x? The range of f of x is between 0 to 1, right? And this the range must include the domain of the outer function. The domain is the values that are greater than 2, 3, 4, 5, 6, and this is between 0 to 1. So means range does not include the domain of the function, because the range of the inner function f of x does not include the domain of outer function f of x, right? That is why we cannot form the f composition f. The inner function range must include the domain of the outer function, then the composition is possible, otherwise it is not possible. Question number 7. The diagram shows the curve with the equation, this is a curve, and the line The curve and the line intersect at the point A and B. So these are the points of intersection of curve and the line. Part A, find the coordinates of A and B. So just find out the points of intersection. We have y equals to this and y equals to this, just comparing. So 3x minus 2 and its power is 1 by 2. This would be equals to 1 by 2 x plus 1. Okay, so to get rid of square root, we have to do squaring on both sides. Squaring on both sides. Okay, on the left side, the square and the squaring is cancelled, 3x minus 2. And on the right side, we have half x plus 1 whole square. Okay, further simplification, 3x minus 2, this would be equals to 1 by 4 x square plus 1 square is 1 and 2ab, so plus x, right? Okay, now shifting all the terms to the left, we have 1 by 4 x square plus x plus 1 minus 3x plus 2, this would be equals to 0, right? Okay, now simplifying the like terms. So x square term is just 1 by 4 x square. X term we have minus 2x, x minus 3x, and 1 plus 2 is just 3. This is equals to 0, right? Now let me multiply throughout both sides of the equation by 4. So we have x square, 2 times 4 is 8x, and 3 times 4 is 12. This would be equals to 0, right? Now this is a quadratic equation and a variable x. Let me factorize this equation. 1 times 12 is 12, and 4 times 3, we cannot do 4 times 3. 2 times 6 is 12. If I can do 2 times 6 is 12, and minus 2 minus 6 is minus 8, yes. 2x square minus 2x minus 6x plus 12, this would be equals to 0. X is common, x minus 2 is left, minus 6 is common, x minus 2, this would be equals to 0. We have the two factors, x minus 2 and x minus 6 would be equals to 0. From here, x is equals to 2 and x is equals to 6. So we have two valid coordinates for the x coordinates are 2 and 6. Now let me find the corresponding y coordinates. To get the corresponding y coordinate, let me substitute the x values 2 and 6 one by one into this line to get y, half x plus 1, right? Okay, let me do this over here. If I draw the line. Okay, so y is half x plus 1, right? Okay, at x is equals to 2. At x is equals to 2, y is 2 by 2 plus 1, 1 plus 1, which is 1. The next is at x is equals to 6. Y is 6 by 2 plus 1. 2 times 3, 6, 3 plus 1, which is equals to 4, right? Now from here, when x is 2, we have y is equals to, what is y? Y is 1. And when x is 6, y is equals to 4. Okay, now we have a coordinates 2, 1 and 6, 4. From here we have 2, 1 and we have 6 and 4. Okay, now let's see which are the x and which are the y. So a is your 2, 1 and b is your 6, 4, right? So the a coordinate is 2, 1 and the b coordinate is your 6, 4, right? Now for part B, hence find the area of the region enclosed between the curve and the line. Okay, area between the curve and the line we have to find. Okay, to get the to find the area between the curve and the line, basically, as you can see, the curve is above the line, so we have to do area of a curve minus area of a line. And area of a curve is, so we need to integrate the curve between the two x coordinate 2 to 6, right? The curve minus line, that is the shaded area, we can say, or area between the curve and the line, right? Okay, so area between the curve and the line, since curve is above, so area of curve minus area of a line. Curve is above the line, so this is just the integration. So we have to integrate the curve between 2 to 4, 2 to 6, because 2 and 6 are the x coordinate, and the curve we have 3x minus 2, power is 1 by 2 dx, and minus, we have to integrate the line between 2 to 6. The line is x by 2 plus 1 dx. right? Okay, so for this integration we have to use a power rule, but for power rule we must have a derivative, so we have to complete the derivative first. So how can we complete the derivative? We have to take multiplying and dividing by 3. So 1 by 3 and 2 to 6, we have 3's inside, we have 3x minus 2 power 1 by 2 dx minus, what is integration for this? 1 by 2 is outside, x integration is x square by 2, and 1 integration is just x between 2 to 6, right? Okay, further simplification, 1 by 3, we have let me apply the power rule over here. Derivative is complete. 3x minus 2 power is n plus 1. 1 by 2 plus 1. 1 by 2 plus 1 is 3 by 2, divides 3 by 2, minus x square by 4 plus x, and its whole integration is between 2 to 6, right? Okay, now further simplification, 1 by 3 and 3 by 2 is just 2 by 3. 3x minus 2 power is 3 by 2 minus x square by 4, 4, and minus x, 2 to 6, right? Okay, we have 2 by 9, 3x minus 2 power 3 by 2 minus x square by 4 minus x, this is 2 to 6, right? Okay, now substituting the limits. 2 by 9, upper limits 6. Okay, let me just solve. 3 times 6 minus 2, 16. Its power is 3 by 2, 64. 64 minus 6 square is 36 over 4 minus 6. This is my upper limit. Subtract the lower limit. 2 by 9, it's 2. So 3 times 2 minus 2. 3 times 2 minus 2, 4, and its power is 3 by 2, 8. Times 8 minus 2 square is 4 by 4 minus 2, right? Simplify this further. We have 2 times 64 over 9, 128 over 9, and 36 divides 4 is minus 9, minus 9 minus 6, minus, we have 2 times 8 divides 9, which is negative 16 over 9, and we have 1, so negative times negative is positive 1 and positive 2, right? For this simplification, we have let me simplify the constant numbers first. 1 plus 2 minus 9 minus 6. 1 plus 2 minus 9 minus 6, we have minus 12. And for 9, we have 128 minus 16 divides 9, plus 112 over 9, and then subtracting 12. This is 0.444. Okay, this is 0.444. This is the area between the curve and the line. Or we can also write this as if I can do 12 times 9 is this, and minus 112, this is 4 by 9. This is also equals to 4 by 9 in terms of fraction. Question number 8, part A. The curve y equals to sine x is transformed to the curve y equals to 4 sine half x minus 30 degree. Describe fully a sequence of transformations that have been combined, making clear the order in which the transformations are applied. Okay, so we have, this is the base function or the parent function, and the transformed equation is y equals to 4 sine half x minus half of 30 is 15 degrees. Okay, so we have 3 transformations that are applying over here. The first, something is multiplying with the sine function, and this is a stretch in y direction, and something is multiplying with the variable x, and and this is the stretch in x direction by a factor of its reciprocal, and something add or subtract, that is a horizontal translation, right? So we have three types of transformations are over here. Oh, sorry, I have to take dividing, taking 1 by 2 common. So basically we're multiplying by 2. Yeah, this is 60, not 15. I messed up, sorry. This is 60. Okay, so the first transformation is we have a translation, horizontal translation of 60 degree. Translation of 60 degree. The second is we have a stretch in y direction by a factor of 4. Stretch in y direction by a factor of 4. And the third transformations applying over here is a stretch in x direction by a factor of reciprocal of 1 by 2. Stretch in x direction by a factor of reciprocal of 1 by 2, which is equals to 2. So these are the three order of transformations we are applying on the base function to get this transformed function. Now for part B, find the exact solutions of the equation. This equation would be equals to 2 square root of 2 for theta x is between 0 degree to 360 degrees. Okay, so let me simplify this. Sine of 1 by 2 x minus 30 degree, this would be equals to 2 square root of 2 over 4, right? And we have sine of 1 by 2x minus 30 degree, this would be equals to square root of 2 over 2 times 2 is 4, square root of 2 by 2, or we can also say this is 1 over square root of 2. Okay, so here we have 1 by 2 x minus 30 degree, this would be equals to sine inverse of 1 over square root of 2, right? What is sine inverse of 1 over square root of 2 in terms of degree? Converting my calculator into degree first. Sine inverse 1 divide square root of 2, 45 degrees, right? Okay, and here sine is positive, so we have to consider in the domain is between 0 to 360, the whole circle, so we have to find in which quadrant sine is positive by using the cast rule. Okay, if I draw the coordinate, you guys can see. Okay, if I use the cast rule, we have C A S T. Sine is positive in the first quadrant, which is 45, and in the second quadrant. So for second quadrant, we do 180 minus 40 theta value, 180 minus 45. Yes, we can see. Okay, so we have two values for theta x, right? Okay, so for first quadrant, we can solve 1 by 2 x minus 30 degree, this would be equals to 45, and what is half x? This would be equals to 45 degree plus 30 degree, right? 45 plus 30, this would be 75, and 75 times by 2, we have x is 150 degrees, right? Okay, now for sine is positive in the second quadrant, which is do 180 minus theta. For second quadrant, we can say half x minus 30 degree, this would be equals to 180 minus 45. 180 minus 45, this is 135, right? And half x is equals to 135 degrees plus 30 degrees, right? In 135, let me add 30 and times by 2, which is 330 degrees. So x is 330 degrees. So both the values 150 and 330 belongs to the domain between 0 to 360 degrees. So these are the two exact solutions of the equation. Question number 9, the equation of a circle is this. Part A, find the coordinates of a center of a circle and the radius. Hence, find the coordinates of the lowest point on the circle. Okay, so first let me find the center and the radius of a circle. So if I can rearrange the terms, combining the x terms, x square minus 6x plus 6x, sorry. And the y terms are y square minus 2y, and the constant is minus 26. This would be equals to 0, right? Okay, so completing the square over here, so we have x square plus 6x, so 2 times 3 would be 6, so 3 squared is 9, right? And subtract 9 as well, right? So plus y square minus 2y, and you have just this is 1, so adding 1 and subtracting 1, minus 26, this would be equals to 0. X square plus 6x plus 9 plus y square minus 2y plus 1 minus 9 minus 1 minus 26, this would be equals to 0. This is x plus 3 whole square, this is y minus 1 whole square. Okay, let me simplify. Minus 9 minus 1 minus 26, this is 36, so equals to positive of 36. Okay, now this is equation of a circle. If I compare this with x minus a whole square plus y minus b whole square equals to radius square, right? So we can find out the center of a circle. Center of a circle is a and b, which is minus 3 and 1. This is the center of a circle, and the radius of a circle is r square, which is equals to 6, right? So now we have the center and the radius. The next thing is to find the coordinates of the lowest point on the circle. So the lowest point is the bottom point. So since the center is minus 3 and 1, so if we move 6 units from 1, 6 units down, we are at point negative 5. Let me show you guys if I draw the circle over here. Okay. Okay, so if I use the scale for centimeter, yes, so this is 0, 1, 1, 2, 3, 4, and so on. And we have downward, we have minus 1, minus 2, minus 3, minus 4, and minus 5, right? And for x as well, you have 1, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, and you have on this side we have 1, 2, 3, 4, 5, 6. Okay, so the center of a circle is minus 3, 1. X is minus 3, minus 1, minus 2, minus 3, and the y value is 1. So this is the center of the circle. So what is the lowest point? If we draw the circle considering this center, the lowest point is the bottom point, right? From this point, we have the radius is 6. The radius of a circle is 6. So 1, 2, 3, 4, 5, 6. Let me show you guys. So from here, 1, 2, 3, 4, 5, 6. So we are over here. The lowest, this is the lowest point for the circle, and this is x is negative 3 and the y is negative 5. So this is the lowest point of a circle. So we can say that the lowest point on the circle is negative 3 and negative 5. Now for part B, find the set of values of a constant k for which the line with the equation y equals to kx minus 5. This line intersects the circle at two distinct points. When the line intersects the circle at two distinct points, it means that the discriminant is greater than 0. Right, so for point of intersection, we have the equation of circle and this line. So we an equation of circle, we just have to substitute this equation, the y value kx minus 5. So equation of circle is x square plus y square is kx minus 5 whole square plus 6x minus 2 times of y kx minus 5 minus 26. This would be equals to 0. Right, okay, let me simplify. So x square plus k square x square plus 25 minus 2ab, so minus 10 kx plus 6x minus 2kx plus 2 times 5 is 10 minus 26. This would be equals to 0. Okay, so simplifying further, we have so let me simplify the x square term first. Right, so the x square plus k square x square, right, and the x terms with kx, we have minus 10 kx minus 2 kx, so this is minus 12 kx, and the other term is just positive 6x. The constants are 25, 10 and minus 26. Let me simplify this. 25 plus 10 minus 26, which is 9, positive 9. This is equals to 0. So now the x square coefficients are 1 plus k square, and the coefficients of x are 6 minus 12x, and the constant is just 9, equals to 0. Right, okay, now we have given the information that it intersect at two distinct points, at two distinct points. It means the discriminant is positive. Right, so we have to find the discriminant. B square minus 4ac, this must be greater than 0. Right, okay, so this is a b, 6 minus 12k whole square minus 4, the a value is 1 plus k square times c, which is 9. This is greater than 0. Right, let me simplify this further. We have 6 square is 36, 12 square is 144 k, and minus 2ab. So we have negative 2 times 6 times 12. This is minus 144k. So minus 144k, and minus 3 times 9 is 36. So and times 1 and minus 36k square. This is greater than 0. Okay, so the k square terms are minus 36. No, there is another, this is also the k square term. Let me simplify this. So let me simplify the k square term. 144 minus 36. This is 108 k square. 108 k square. K term is just 1, which is minus 144 k, and positive 36 and negative 36 is cancelled. This is greater than 0. Right, now let me solve for k. So k is common. 108 minus 144 108k, sorry, this is greater than 0. Right, let put this equals to 0. So k into 108k minus 144, this is equals to 0 to find the roots of this equation. So from here we can say k value is equals to 0, and 108k minus 144, this would be equals to 0. So the k value is 144 over 108. Right, let me simplify. 144 over 108, which is 4 by 3. So we have two values for k. So since this is a quadratic equation in a variable k, and this is positive, sorry, and the k square coefficient is positive. So if I draw the parabola, as you can see, let me draw the parabola over here. We have two roots, right? One root is 0 and the other root is 4 by 3. What is 4 by 3? 1.3, right? So the first root is 0 and the other is 4.3. This is a parabola. This is 0, 1.3. This is 4 by 3. right? And k-square coefficient is positive, so its opening is upward. Now we have to find the values of k when the discriminant when it has two distinct roots. It means when the curve is positive, it is greater than 0. So all the values of k, when values of k that are lower than 0, its curve is positive, and more than 4/3, the curve is positive, right? Okay, so the answer, or we can say that the solution is k value is less than 0 and k values are greater than 4/3. So these are the two solutions. Question number 10. The equation of a curve is such that its second derivative is given to us. The curve has a stationary point at -1 and 9/2. Part A. Find the nature of the stationary point. To find the nature of the stationary point, we have to put the stationary point in the second derivative, and if it is positive, it is minimum, and if it is negative, it is maximum. So let's see. So we have to find the second derivative at the stationary point at x is equals to -1, because we just need x. 6 times -1 square minus 4 over -1 cube. So this is just 6 and positive 4. This would be equals to 10. This is greater than 0. So we can say that -1 9/2 is minimum stationary point. Because the second derivative at that point is positive. Now for the second part, find the equation of a curve. We have the second derivative. We can find the equation of a curve by integrating this curve twice, right? So we have d2y over dx square integration with respect to dx equals to 6 is outside, integration of x square dx, minus 4 is outside, integration of x power -3 dx. Okay, so here you will get dy over dx, the first derivative, it's reduced to the first derivative, 6x cube over 3 minus 4, and its power is x power -3 plus 1, so -2 over -2, -2 over -2 plus some constant of integration. So further simplification, we can say dy over dx would be 2x cube plus 2 over x square plus c. Okay, to find the value of constant of integration, we know that at the stationary point, we have given at the stationary point the first derivative is equals to 0. We can find the stationary point by putting the first derivative equals to 0. So we know that dy over dx, this would be equals to 0 at this point, right? So we have to substitute this condition. We can say that dy over dx, this is equals to 0 at x is equals to -1, right? Let me substitute this condition to get the value for c. We have 0, 2 times -1 cube plus 2 over -1 square plus c, right? So 0, this would be equals to -2 plus 2 plus c, so the c value is just 0, right? So from here, the first derivative dy over dx, this would be equals to 2x cube plus 2x power -2, and the constant of integration is 0. Now to get the value of a curve, we have to integrate it further. Taking integration on both sides again, we have y over here 2x power 4 over 4 plus 2x power -2 plus 1, so -1 over -1 plus d, the constant of integration, right? Now to get the value of d, what we have to do, we need to use the condition, the points -1 and 9/2, the stationary points which we have given, right? So y value is 9/2, this is 1/2, x4 is -1 power 4, this is -2 over x, which is -1, and the d value, right? Okay, further simplification, we have 9/2 and minus this is positive, so shifting over here -1/2, and this is positive -2, and this is the d value. Okay, let me simplify this. What is 9/2 minus 1/2 minus 2? This is equals to 2. So the d value is equals to 2. So we can say that the equation of curve is y equals to x4 over 2 minus 2 over x plus 2. This is the equation of the curve. Now for part C, show that the curve has no other stationary point. For stationary point, we have to put the first derivative of the curve equals to 0. And from part B, we got the first derivative, which is 2x cube plus 2 over x square. We have to put it equals to 0 and simplify for x. So 2x cube, this is equals to minus 2 over x square. Now for cross multiplication, x power 5 is equals to minus 2 over 2, which is equals to minus 1. So x power 5 equals to minus 1, and to solve the value of x, taking the power 1 by 5, yes, the fifth root on both sides. The fifth root of minus 1, let me check, fifth root of minus 1, this is minus 1, yes. So x is equals to minus 1 is the only stationary point, right? Now for part D, a point A is moving along a curve and the y coordinate of A is increasing at the rate of 5 units per second. Okay, so point A is moving along the curve, the y coordinate of point A, that is increasing at a rate of 5 units per second. So this means dy over dt is 5. Find the rate of increase in x coordinate of A. We have to find dx over dt at a point x is equals to 1. What is dx over dt? Choosing the chain rule, we have dx over dy times dy over dt. So we have the value of dy over dt, which is 5. We have to find dx over dy at x is equals to 1, right? Okay, so we have dy over dx, which is 2x cube plus 2 over x square, right? So at x is equals to 1, dy over dx at x is equals to 1, we have 2 plus 2, which is equals to 4, right? But we have to find dx over dy, the reciprocal. So we have to put into the first equation this part. We have dx over dt, the reciprocal of this is 1 by 4 times this value is 5, so this is 5 by 4. So the rate of increase of x coordinate of A at the point where x is 1 is 5 by 4, right? So that was the last question of our paper. If you have any queries, please let me know in a comment section, and please subscribe to my channel. Thank you for watching. See you next time. Take care.